Hi everybody, so this is just a short video for the second lesson on linear motion, and this is again carrying on from what you've learned in year 12, and this lesson has to do with conservation of momentum. So in the first lesson we looked at change in momentum or impulse, and this one has to do with conservation of momentum. So the thing is, momentum is conserved whenever there is no external forces acting in the event of a collision or an explosion. Now, I wonder if you have ever thought, why are they talking about external forces? Why didn't they just say forces? Now, the thing is, there's actually what we call internal forces as well as external forces. Now, this brings us to the concept of a closed system. So a system can consist of a single object or more than one object, and in a closed system, this is one which is free from all external forces. And the way that we depict or show a closed system is you have your objects. So there's one object here and there's another object there. So there are two of them. And to show that it's a closed system, we kind of draw a little rectangle with dotted lines around it, and this implies it's a closed system, there's no external force. So what on earth is an external force, and how is it different from internal forces? So in a closed system where objects are interacting with each other, when I say interacting, it means exerting a force on each other by collisions. These forces are called internal forces. Okay, so what's an external force? So an external force is like when you hit a ball with a bat, that's an external force. If you're braking, accelerating, so to change the motion of the whole object, so those are external forces. Gravity is an external force. And another one, so when there's an external force, momentum is not conserved. And another thing to look at where there's an external force is that if you bounce a ball on the ground, the ball's going to hit the ground, but the ground does not move. So one of the objects is not moving. So the ground does not yield. So what's happening is that the ground offers a reaction force when the ball is in contact with the ground for that brief moment in time, and that reaction force is an external force. Okay, so when we're looking at conservation of momentum in 2 dimensions, we need to draw our vector triangles. We have to take direction into account. So what does this mean? That the total momentum before a collision or an explosion is equal to the total momentum after the collision or an explosion. And the way we do that is the individual momentum of each of the 2 things before the collision will be equal to the sum of the individual momentum of the objects after the collision. So, and there are some problems on conservation of momentum in your booklet. At the moment, I don't have my booklet with me at home, but I will go into school and retrieve a booklet a little later on today. And I will put some notes up for you, which you can copy. All right, bye for now.